Hello, my name is Babak. Heat waves have been responsible for a large number of lives lost, and they are expected to grow in their intensity and frequency. Therefore, urgent mitigation and adaptation strategies are required for sustainable urban planning. The Sustainability and Data Sciences Laboratory at Northeastern University worked with the town of Brookline, Massachusetts, to understand the potential public health impacts of anticipated heat waves. For this purpose, we used the risk framework proposed by Intergovernmental Panel on Climate Change. This framework is used for global problems. Therefore, we adapted it into a local scale for the heat wave problems, considering the layers of vulnerability, exposure, and hazard. We used the Census 2010 block groups to partition the different parts of the city into different sectors and used the American Community Survey to calculate the population ratio for each vulnerability population. We used the remote sensing data from Landsat satellite to calculate the land surface temperatures over a heat wave period. In the next step, we added these vulnerability factors into an overall vulnerability map of the town, and we averaged the land surface temperatures over each block group to calculate the overall hazard map. Then we used these two maps to calculate the heat wave health risk map of the town for the current situation. To study the future condition, we used a regional climate model with three different climate change scenarios. We calculated the average temperature changes for two future time frames. Then we picked the pessimistic scenario, added these average temperatures into the current hazard map, and concluded with two future hazard maps of 2030s and 2070s. In the next part, we used the cooling center analysis of the 6 public cooling centers of the town as an adaptation strategy. We did the buffer analysis for two distances of a quarter mile and half a mile to these cooling centers. In the next part, we did tree canopy analysis as a mitigation strategy. We used these 4 factors in this equation to calculate the ambient temperature in different parts of the town. Then we used it alongside the percentage of tree canopy to do a regression analysis. Therefore, we could calculate the required increase in tree canopies area for the highest hazard parts of the town, so that we could increase the mean temperature of highest hazard level into one level down. As another possibility of mitigation strategy, we calculated using the roof outline map the percentage of roof outlines in each block group to the area of that block group. I'd like to conclude this presentation with a few points. First, the higher the ratio of poverty we expect, the higher the hazard. This is because of denser built areas. Second, a notable caveat in analyzing the future scenario is the unavailability of detailed urban development plans, which is the most important factor in creation and intensity of urban heat islands. Third, as we see in our analysis for the roof percentage area, the highest available roof percentage are in the parts of the town which we have the highest level of hazard. Therefore, we suggest to focus the future mitigation strategy on different possible strategies of roof improvement. Last but not the least, recording local weather data in different parts of the town is suggested for increasing accuracy and decreasing the uncertainty in the future studies. Thank you for your time.